All right. So yeah, today we're going to go over section 20. So one thing I'm going to emphasize is that know that we're only a few sections away from the end of this module, and then we'll go into a module project, right? So after the end of section 24 is when we'll actually be starting project week again. Woo! Hopefully you guys accept. Yeah, that's the right reaction, Bardo. Just, yeah. But I think this will be really just one. So one thing I'm going to let you guys know ahead of time is that before sections 20 and 21 are probably the most relevant to this particular project coming up. So my suggestion is make sure you really understand the material in this section, go over it. You'll probably revisit it once you start the project too. Basically, it's the hypothesis testing and effect size. And we'll talk about next time about on section 21, we'll talk more about some of those other tests we can do as well. Okay, sound good? Awesome. All right, so I'll go ahead and start sharing my screen. And let's see here. Here we go. Okay. So, all right, so you guys should be able to see my screen right now. And I got these fancy dancy table of contents. That way you can kind of see what's going to happen. All right. So our first thing, basically, we're going to get into, oops, I actually realized I'm not even talking about this first. Experimental design. So this section in particular, you can summarize as section 20 as experimental design, statistical tests, all of these amazing things. So one thing you'll notice is that when we talk about statistical tests, we kind of talk about it as being an experiment, which kind of seems kind of weird. Sometimes I think when we're talking about statistics as our experiment, we're usually not, like, sometimes we're just observing rather than actually changing things, which you would think of like a science experiment. But in a lot of ways, it really is like a science experiment in the sense that we're observing certain aspects. We're deciding, you know, who are we observing or how are we observing it. So we actually approach this with the scientific method. So just a thumbs up, and this could just be like back in like maybe middle school, is who, well, first of all, who's heard of the scientific method? Like, hopefully that's good. I see some thumbs up. All right, awesome. All right, my physics heart is happy that you guys at least heard of the scientific method. So the scientific method, right, in general, is essentially a process, right? And so we'll see this kind of emphasis. And so basically a good science experiment is in a lot of ways a good statistical experiment or statistical test. So basically the big part about having data is that if you don't have a good experiment, a good data set, you're not going to be able to get very good results for whatever you're trying to test for, right? So if your test already is like, in a sense, like you're feeding in, you know, junk data, you're not going to get anything useful because you're feeding in a bunch of junk. So this is where experimental design is really useful, okay? So with the scientific method, this is kind of summarized, and people phrase it in different ways. It's all basically the same idea though. For the record, if you are a scientist, like in the sense of like, you know, like a physicist, a biologist, you're not explicitly thinking, oh, the scientific method, this is the process we're going through. So the first thing basically is a question or observation, something that we're always like approaching. We're like, okay, we need to know how to approach, like we find something interesting, or like, you know what, I want to know about this thing, which is kind of like, as data scientists, you're asking a question for your stakeholder. You know, what is the question that we want to ask, okay? And then one thing, important part that people really tend to forget is this background knowledge. A lot of times we'll talk about it as domain knowledge as a data scientist, basically understanding what is the specifics of my situation I'm looking at. So for example, if you are exploring housing prices, it's good to know, well, what does the real estate market look like? You know, what are things that I need to care about? You know, if you're looking for examples of stock market, you should be familiar with, you know, different terms and different things, that metrics that the stock market does. This is where background knowledge can be really useful, especially those of you who came from another career. Understanding that domain knowledge can be really useful in the sense of like what your data is telling you. If you are familiar with your where the data comes from, you're going to have an easier time explaining parts that are going to be kind of weird, or catching things ahead of time before you proceed forward in a hypothesis test or something. Okay. So next is your hypothesis, which hopefully you guys all understand. A hypothesis now essentially is, I remember back in middle school when I was teaching this stuff, people would say it's an educated guess. I don't like that word. And hypothesis in a lot of ways is what we assume, what we want to be true, or what we want to test out. Essentially, it's like what kind of thing are we actually trying to test? I would sometimes like make my like middle school students when they're doing their science fair experiments, I wouldn't say like an if then statement. Like if this happens, then this will happen. I would say an if then and why. Like why do you think this will happen? And so this hypothesis really in a lot of ways is saying, what are we expecting an effect to be? Okay, and we'll see this very explicitly stated in hypothesis statistical test. Okay, but again, this is kind of like you're trying in a sense like to like you're trying to figure out what doing your experiment, you're trying to see what happens, what that effect is. Okay, and so 4 is your experiment. So your experiment basically ties directly to your hypothesis, saying, okay, what do I care about? And a lot of times when I say experiment, our experiment is not necessarily going to be something that we have control over. Sometimes you do. Sometimes it's just the data you have, and your experiment is saying observing from that data set. So no, those are still experiments in that way, but you have to be kind of aware of what that looks like. And then of course your analysis, conclusions, basic stuff that you would think like, say, what does this mean? Because just because you have a positive thing on your hypothesis, say, oh, my hypothesis was correct, you still have to determine, well, does it mean anything? Or is it technically correct, but not in the way that I expect? Or maybe your hypothesis is correct, but you realize that your data is corrupted in the sense that it's not going to give meaningful results and you need to explore further. Okay, so some steps of making a good experiment. Just these are things in the curriculum I already talk about. So making a good experiment, you should have, control groups, randomized trials, a good sample size. So we kind of talked about this a little bit. It's like the more people you have, the better. As we saw, like with our, I'm trying to remember when this was. I think it was just on Tuesday. We talked about having a larger sample size will actually really help you with the central limit theorem. Is that if we have many, many people in our sample size, we actually get very close to our population mean. So this is where a large sample size is really actually important. And then make sure it's reproducible. Making sure that, for example, you're taking this out and actually being able to do this over again for new situations or collecting new data. So this might be, this kind of goes like a little bit like, oh, the physical parts, like, can you reproduce this experiment? But also in the way of like doing statistics, like, can you reproduce this part in the sense that, can you repeat the experiment with a different sample and still proceed forward? This is kind of an important part that it's kind of subtle, but something I always think good about. So one thing I'm going to point everyone to is this YouTube channel is Healthcare Triage. By chance, I doubt anyone's seen this because it's not super popular. They make really great videos. I just think they're not very popular. Has anyone heard of Healthcare Triage on YouTube? Yeah. So I would say the reason why this is not really popular is not because they don't make videos, but they talk a lot about statistics. And I think that means it's really useful. So if you want to see, this person, oh shoot, I forget his name now, Aaron Carroll. He's the one who leads this. He's a physician, and basically talk about some different studies and stuff like that. And they talk about, he actually talks about the p-value, significance level and stuff like this. He actually talks about those numbers, and it's really cool because you can basically hear him talk about meta-analyses. If you want to get a feel for how to use these terms, in this case, in the domain of healthcare, this is actually a really great, I really suggest this channel just for anyone to curious like what those numbers are, or just to be able to hear the general part. Again, pretty cool. So highly recommended. All right. So anyway, that's experimental design. I kind of went through it really quickly. There's a lot more detail in the curriculum itself, but I'm not going to read that off to you guys because you guys can read pretty well. At least I assume so. I don't have you guys read out loud. So this brings us to our real big part, hypothesis tests. So we